All right, in this next section, 7.8 for probability and integration, we're going to take a look at how we can calculate probabilities from a probability density function. So in the field of probability, if there's a quantity, for instance, maybe an event or something, capital X here, the probability of this falling in the value of this falling between value A and value B inclusively can be found by integrating a so-called probability density function for this random variable x. So what's the probability of x having a value between A and B? Well, it's the integral of the probability density function for that random variable. So we know that a probability is a number between 0 and 1, can't be less than 0, can't be greater than 1. So if we just start with a density function, there's nothing that says that when we integrate over all possible values that we'll actually get 1. So we have to make sure that this is true. So in order to take some function, such as the function 1 over x squared plus 1 in example 1, if we were to integrate this from negative infinity to infinity, you'll find that this does not equal 1. So we can make this into a probability density function by artificially inserting some yet to be determined normalization constant. So we can call this a normalization constant. So we can do the integral from negative infinity to infinity of this now that we have this normalization constant c inserted, and we'll get the answer to be some function. So the integral will be some function of some function of c. So then we can set that equal to 1 and then solve for what c needs to be in order that this integral equals 1. Okay, so let's go ahead and take a look at that. Example 1, we'll do exactly the setup that we have. Negative infinity to infinity, c over x squared plus 1 dx. Of course, this integrates into arctangent, or inverse tan, of x times our normalization constant that we're trying to determine, c. Now we want this to be equal to 1. Now, since this is an improper integral, I should actually not put those infinities there. What I should do is have a limit as r goes to infinity, let's say, of this expression. And then I'll replace these with negative r and r, respectively. There we are. So now we can evaluate the antiderivative without, quote, plugging in infinity. So this is c times, this would be the inverse tangent of r minus the inverse tangent of negative r. Now, tangent and therefore inverse tangent are odd functions. Because they are odd functions, that means I can factor out negatives from the argument and pull them out in front as a coefficient. So the fact there's a negative 1 here in front of this r, it's negative r, I can pull this out, so then I'll have minus negative 1. Well, minus a negative is really just a double negative, so a positive. So using the fact that inverse tangent is odd, I can go ahead and write this as the following. I can write this as, well, this would become, let's write this in red, this would become plus tan inverse of positive r. So I really have two copies of that. So this would become 2c inverse tangent of r. And remember that when you are evaluating a limit as your variable goes to infinity, you're really checking to see, does the function have a horizontal asymptote in that direction? And arctan does have a horizontal asymptote, pi over 2. So this is 2c times pi over 2, which is just pi times c. Now, since we want this to be equal to 1, remember that we want this to be equal to 1, so let's, in the very beginning, let's go ahead and just say 1 is equal to this, and then go through everything. So this implies 1 is equal to pi times c, which implies c is equal to 1 over pi. That is our normalization constant. So our probability density function is actually 1 over pi times x squared plus 1. All right. So now we are asked to determine the probability of the random variable x falling between a value of 1 and 4. Well, this means, so the probability of x, our random variable, between 1 and 4, we'll get used to this notation. This is going to be equal to the integral from 1 to 4 of our probability density function. Oops. As before, this integrates to arctangent, so tan inverse of x between 1 and 4. So this is, put this over pi, this would be tan inverse of 4 minus, I'm running out of room, let's move down a little bit. Tan inverse of 4 minus tan inverse of 1. Which simplifies just a little bit more. This is, can't simplify tan inverse of 4, so that just stays there. But tan inverse of 1 is going to be pi over 4. And there we go. And since this does represent a probability, it would probably be nice to actually think of this as a decimal and not as some exact answer. So rounding to the nearest 1/100th, this is a probability of 0.17. There we go.